Hey folks, I hope I'm audible. Today's leetcode problem is search a 2D matrix. Let's understand the problem statement. You are given an element to an integer matrix. The following two properties. Each row is sorted in a non-decreasing order. The integer of each row is greater than the last integer of the following previous row. Given an integer target. Okay. So let's understand the problem statement uh, on the blackboard so that we'll able to understand and I can explain clear. Okay, so so this is the matrix. So this is the matrix given and given the target value. Consider the target value is 10. So we have to figure out the if the 10th element is present in the matrix or not. If the 10th element is present in the matrix, we have to return the true. We have to return the boolean value. So how do we do it? Consider if you want to do it in a brute force. So generally, we'll iterate uh, like 2D array. So how will you do it? I'm showing it. M I plus plus. This is nothing but the row. We have to iterate column wise also. So iterating the column. So we have to check if matrix of I of j equal to target, then return true. Okay. Else and return false. So this is what about the brute force and the time complexities of m into n as we are traversing the two loops uh, and the time complexity, sorry, space complexities O of 1 because we didn't use any other data structure. Is there any other, can we optimize it? Can we break down the brute force into most optimized version? Can we do it? Yeah, we can do it with binary search, right? How will we be able to do it? Let's understand. So, let me copy again this array. So, this is the array. So, in binary search, we generally um, transfers 1D array, right? So, can we bring this whole 2D matrix in array? Yeah, we can do it. How will we be able to do it? Let's imagine. Okay, let's imagine. Okay, whatever the assumptions I'm going to teach, it is just an imagination. Based upon that is a imagination, and we'll break down this whole thing 2D matrix into most optimized. So let's consider the 2D matrix in 1D form 1375357. Okay, let me write here so that all elements will be present. Okay, 1 3 5 7 10 11 16 20 23 34 and 60. Consider this. I mean, it is an imagination array. Okay, imaginary 1D array. Okay, I'm fitting the whole 2D matrix into 1D array. So consider in the for what we use the binary search. So first, generally, it will take the two pointers, which is left, and the right pointer, which is on right. But we, how to find out? But in the 2D matrix, to find out the last element, we can't do it generally how we do it in 1D array, right? How will we do it? Just see, left equal to 0 and right is the length of row into the length of column minus 1. See, how many how many rows are there? Three rows are there. I mean, how many columns are there? Four columns are there. Minus one, which is 11 elements. So let's count the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is what I exactly meant. Okay, so to find out the last element in the 2D matrix, we just generally multiply number of rows into number of columns minus 1. That gives the last element. Okay, the right value if you want to find out um, the binary search point. Okay, so then the next step to find out the mid. So generally the binary search will do mid is just mid equal to left plus right minus left by 2. This is right. So but we have to match the value of mid value to the target, right? We can't just use nums of mid equal to target, because this here goes wrong. I mean, it is suitable for 1D matrix, but not 2D matrix. Right? So, see, as an imaginary array, let's copy this. As I mentioned earlier, we are just imagining this whole 2D array in the form of 1D array, right? Yeah. So, we are imagining the whole 2D array in the 1D array, right? So, the mid value would be, as we are converting 2D into 1D, right? So we are removing the number of rows. Okay, we are just removing the all the rows, and we are forming the single row and lot of columns. So that is what we are doing. So how do we get? I mean, the how do we find out the I value and the j value so that it point out the mid value? How do we do that? Just index by column will give the, and index by, sorry, index percentile column gives the jth 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 column. You can say it is a column, it is nothing but row. So the same way, the mid value equal to nums of mid by column and mid or percentile column. This gives the mid value. Okay, I mean, in the 2D matrix, if you want to find out the mid value, so we have to nums of that particular index, whichever, as we are using the mid index, mid by column and mid percentile column. This is nothing but row, this is nothing but column, which gives the mid value, right? So after attaining the mid value, we just do simple things. Just mid value equal to target. Then it is true. Return true. Else if mid value less than target, then see mid value is less than target means the mid value is greater than target. So that means right equal to mid, sorry, we have to increment lower right as mid value is greater. So left equal to mid plus 1, else right equal to mid minus 1, right, else return false.